Good day, beautiful people. Swift here. You're watching Swift Tuition, and in this video, I'll be covering simplifying with exponent laws, specifically using products, quotients, zero, negative, and rational exponents. For more free maths help, use the first link below in the group description to join your Grace free WhatsApp group. I'll be sharing selected resources, updates, and occasional free sessions there. If you want weekly tuition, full worked out solutions, recordings, and the premium group, launch prices are going to be $350 to $450 until the 31st of August, depending on your grade. Prices are going to be doubling on the 1st of September. You'll find both links below. A very crucial skill to develop is the ability to simplify a exponential problem. So what I want to do is, through showing you a couple of examples, I'd like to kind of make the intuition a little bit easier. There are different ways that we approach a particular problem if there is a plus sign and if there is a multiplication sign, or sometimes the multiplication sign might not be explicitly given, but things that imply multiplication, such as having brackets, for example, something like this, for example, or just having the dot, which just means also the same as multiply. All three of these mean the exact same thing. Okay, bad example. I should have maybe used the 2 instead, but my point over here is the fact that you need to be careful with regards to whether there's going to be a plus sign or there's going to be a multiplication sign. Number one. And tip number 2 is, if it's not given in terms of a product of prime factors, please convert them into a product of prime factors. Now, in these problems, because we're keeping things very simple, that's not really what you're going to be dealing with. But when things get a bit more complicated and you're solving exponential equations and such, then you do need to kind of think about having products of prime factors, as it greatly simplifies a problem. So let's begin with this. You'll notice that this is 2 to the power of 3 multiplied by 2 to the power of 5 divided by 2 to the power of 2. So in this case, I did say multiply, but I guess I meant more broadly multiply or dividing. When you're multiplying or dividing, the tips are going to be at their easiest at this particular point. So the tips are going to be very easy. All right. I say tips, the strategy is perhaps a better way to phrase it. And that is that when multiplying, numbers with the same base, add the exponents, and when dividing numbers with the same base, subtract the exponents. Okay, so that's basically going to be that. So whenever there's the same base and you're multiplying or you're dividing, the only thing you have to do is just add the exponents. In this case, I've got 2 to the power of 3 multiplied by 2 to the power of 5. You can see clearly that I'm multiplying something, right? And they have the same base. It's both 2 to the power of 3, 2 to the power of 5. At the base, there is the number 2. So if the base is 2 and the exponent is the 3, or for the first guy, and the exponent is the 5 for the first guy, I must add their exponents. So this becomes 2 to the power of 3 plus 5, and that's going to be 2 to the power of 8. That's what this first portion simplifies to. And then, as you can see, I'm dividing afterwards. And when you're dividing afterwards, you just need to subtract the exponents. So in this case over here, I've got 2 to the power of 8 divided by 2 to the power of 2, which means that therefore it's going to be 2 to the power of 8 minus 2, because the exponent was a 2. So altogether, you'd say 2 to the power of 3 plus 5 minus 2, and you'd get 2 to the power of 8 minus 2, and you'd get 2 to the power of 6, which is 64. So that's basically how you would go about doing that. Now, when the numbers get awfully large, oftentimes you're not expected to write it down as a full number, and you can just leave it as 2 to the power of something. But this number itself is fairly small, so we can obviously just write down 64. It's fairly straightforward. Okay. That is that. Another way to look at this is that you can rewrite this particular problem as the following. And when you write it like this, right, 2 to the power of 3 multiplied by 2 to the power of 5, and you take this result and you divide it by 2 to the power of 2, the same idea is going to be brought over here, whereby you're going to add the exponents because you're multiplying. This becomes 2 to the power of 8 divided by 2 squared, and then obviously subtract the exponents in this case, thus giving you 2 to the power of 6. So that is how I would approach that. As you can see, this problem comes in that specific form. You can see that x, and x to the power 4, x to the power 7, x to the power 3, they all have the same base of x. So that what that means for me is that I can add the exponents for the multiplication side, and then I'll obviously then I can add the exponents for the multiplication, and I can subtract the exponents for the division. So this becomes x to the power 4 plus x to the power 7 over x. No, it's not plus, it's multiplied. Let's bring back the eraser. And then obviously I can add, oh, I didn't even do the adding thing. I'll add them up. That's 1, 2, 3, 4. That's 11. X to the power of 11 over x to the power of 3. And I can subtract over here. That's 11, 10, 9, 8. That's x to the power of 8. Okay. Another way to think about this as well is that, in fact, I'll show it to you in the next problem. So that's going to be x to the power of 8. And yeah, fairly straightforward. Next problem. So Swift is reducing a huge algebra expression before it breaks his calculator spirit. We want to simplify fully using positive exponents only and state the values that are not allowed. So how am I going to do this? What I'm going to do is I'm going to, again, apply the exact same tricks, right? But what I'll do is I'll just do a bit of fancy grouping. Because there's multiplication, it's very straightforward. You can just move numbers around without worrying too much about how that's going to affect the problem overall. So I'm going to put the numbers with each other. First of all, just line them up, line up the letters with each other, and then line up line up the A's with each other, and line up the B's with each other. Okay, just so I can show you a different way or a different way to see the problems, but we're applying the same principles under the hood. So as you can see, I've got this 4 over here. I'm going to bring this 4 next to the 3, but I need to still make sure that they're multiplying. So I'll do 3 times 4 over here. Now I'm done with all the numbers, right? There was a 3, there was a 4. I've got a squared and a to the power of -5. So I'm going to have a squared multiplied by a to the power of -5, and then obviously one more time that'll be b to the power of -1 multiplied by b to the power of 4. So we've got that. So I'll group this together, I'll group this together, and I'll group this together, and I'm putting that all over, and that'll be 6 multiplied by a to the power of -1 multiplied by b squared. Right, at all these instances, obviously this dot over here just means same as multiplication, but everywhere throughout I'm just multiplying. I haven't changed this problem at all. I haven't even started simplifying it yet. I've just made it look cute for my eyes. Okay, so now as it stands right now, I would like to obviously simplify a bit further, but before I separate things, let me just do what's very easy. Everything numerator, try to simplify it separately. Everything denominator, try to simplify it separately if it's possible. So I'll do is that'll become 12 multiplied by a to the power of, I add the exponents because I'm multiplying here. That's 2 plus -5. It's not 2 plus 5, it's 2 plus -5. In other words, 2 minus 5. So that'll be a squared multiplied by a to the power of -5 is equal to a. The first guy is 2, and because we're multiplying, we are adding the exponents. It just so happens that the second exponent is a -5. And when you do that, your answer is just the same as 2 minus 5, and that obviously gives us a to the power of -3. So here, I'm going to say a to the power of -3. And then same procedure over here, this is b to the power of -1 multiplied by b to the power of 4. That is b to the power of -1 multiplied by b to the power of 4. That is b to the power of -1 plus 4, and then that's going to be b to the power of +3. That's going to be that. So I'll simplify that to b to the power of +3, and then I've got 6, and then multiplied by a to the power of -1 multiplied by b squared. There's no way for me to really simplify the denominator any further as it stands right now. Now what I'm going to do is I'm going to separate them. Again, I'm multiplying, so breaking them up is perfectly fine. So this becomes 12 divided by 6 on its own, and I'll have a to the power of -3 over a to the power of -1 on its own multiplied by b to the power of 3 over b squared on its own. And then obviously 12 divided by 6 is easy. That's just going to be 2. Then a to the power of -3 multiplied by a to the power of -1. I'm dividing, so this is the same as obviously saying a to the power of -3 divided by a to the power of -1, which means that you could just obviously subtract the exponents. But I'll show you another way to do it. What you can do is if you want to transport this guy from the bottom to the top, or vice versa, you need to change the sign of the exponent. So for example, if I wanted to bring the a to the power of -3 to the bottom, then that would become a to the power of 3, because now that I've brought it to the bottom, the sign can't stay negative any longer. Multiply by a to the power of -1. Now here you're not going to put a 0. You want to imagine as though there's a invisible -1, sorry, times 1 that was here. And so when you do this, you need to leave that invisible 1 exactly where it was. So this just becomes 1 over all of that. So this is how the problem is going to look like. But what I'm going to do is I'm going to bring it the other way around. All right, it's just easier to work with everything in the numerator. So I'm going to bring the a to the power of -1 to the top, which means that I'm going to have a to the power of -3, which is, and obviously multiply by a to the power of -1. And there was also an invisible times 1 at the bottom over here. So as I bring, sorry, it's +1 now because I brought it to the top. So now it's going to be a to the power of +1, right? And then obviously this is going to be over 1. And then this is, again, same procedure. I'll have b to the power of 3 multiply by b to the power of -2 because I brought the guy to the top, but obviously there was an invisible times 1 over here, so we need to leave that invisible times 1. Now obviously divided by 1 is the same as just leaving the numerator by itself, so there's no need for me to say divided by 1 because dividing by 1 does not change a number whatsoever. So I'll just do is I'll just remove that, and then I will remove that as well. And now I've got these groups, and this is obviously going to be 2, and I can add the exponents here, and this makes it a to the power of -2, and I can add the exponents here, which makes it b to the power of 1. And oftentimes they do like to have positive exponents. So as you can see here, this is 2 times a to the power of -2 times b, or another way to think about it is 2 times a to the power of -2 times b over 1, because dividing by 1 doesn't change the problem. But I don't like having negative exponents, so I'm going to transport the a to the power of -2 to the bottom, and when it travels from the top to the bottom, its sign is going to change. So now we're going to have 2b over a squared, and that is going to be our answer for that specific problem. So that is basically how you would approach a problem such as this, right? And yeah, that's about it. Okay, next problem. Now, when a question asks you to simplify and there's a plus sign, even if they did have the same basis, it's not going to be a cute merge and match, right? Even if this was 2 to the power of 0 plus 2 to the power of -3, you can't say, well, plus is pretty much the same as multiply, so this is just going to be 2 and 0 plus -3, and then that's going to be 2 minus 3, and we know that obviously when you have a minus, you can bring it to the bottom of the division sign, so that becomes 1 and 2 to the power of 3, because you need to change the sign. If there's a minus, and that's the same as 1 over 8, and you do that and you'd be absolutely wrong and get absolutely no marks. Okay, so when there's a plus sign, we can't merge and match, even if the bases are the same. There's no combinations possible. So what you're going to do, first of all, is just work with them separately. This is 5 to the power of 0. That's just the same as saying 1. So I'll put 1 down. And now this is 2 to the power of -3, all right? So this is 2 to the power of -3, but in other words, I can really say 2 to the power of -3 over 1, right? Don't forget our invisible multiplied by 1 that's there. You don't really put it in your problems, but just know for now that it is there so that you don't suddenly accidentally replace it with like a 0 or something, right? I've seen that mistake happen far too many times. Okay, then this is going to become 1 plus, and then now I don't like negative exponents. I want to bring it to the bottom, but it's going to become positive when I do that. So it's going to be 2 to the power of 3. And then at the top, I'll still have the invisible 1. So in other words, right now I've got 1 plus 1 over 2 to the power of 3. Now, this is the same as saying 1 plus 1 over 8. Now, because again, we're talking about plus, we can't just merge and match. Multiplication, if I had something like 1 multiplied by 1 over 8, all I just need to do is to multiply the numerator, and the denominator with the denominator. This is the same as 1 over 1, right? Any number divided by 1 is the same, and I can just multiply the top with the top and the bottom with the bottom, and that gives me 1 over 8. Fairly straightforward, right? Multiplication is different. We need to find what is known as an LCD, lowest common denominator. So the objective for us is to look at a number like 1 and ask ourselves, how can I write the number 1 in a way such sure that it has the same denominator as this other number. So oftentimes, if the number has a smaller denominator, you want to bring it up to match the denominator of the bigger number, right? Find the lowest common denominator that you can have between these two. Now, think about 1, right? 1 is a whole, right? That is the same as 1 over 1. But that is just the same as saying 2 over 2 as well. Any number divided by itself is 1, which means the same as 3 over 3 is the same as 4 over 4, so on and so forth, until you realize the same as 8 over 8, right? Another way to think about it is you take 1 over 1 and you multiply it by 8 over 8. 8 over 8 is 1, which means that the number itself is not going to change. You're just taking 1 and multiplying it by 1. So you're not changing the number at all. But now, because multiplication is the matter of lining up the top with the bottom, this gives you 8 over 8, which is another way to just represent this 1 in a way that is going to be more helpful for us in this problem. So this leaves us with 8 over 8 plus 1 over 8. This simplifies to 9 over 8. And that is going to be the final answer to something like this. So why can I just add them now? Because they have the same denominator, you can just add the numerators and that'll be fine, right? I'm saying add, but it depends on this sign, of course. If this sign was a negative, then this would become 8 minus 1, so in other words, 7, right? Something to bear in mind is that if there was more than one term, so let's say it was 8 over 8 and it was like plus 1 plus b, in this case over here, it's not going to make much of a difference. The answer will just be 8 plus 1 plus b, but I advise you to just put brackets around it. So you apply the plus sign over here and you put brackets around this particular portion. Here it doesn't make a difference, but the habits is important because it will make a difference when we're dealing with subtraction. Because I've seen lots of people, when they see subtraction, what they'll often do is, let's say we have a problem like this, right? 1 plus b, is they will say that is going to be 8 over 8. And they will say, okay, minus, okay, it's the same, okay, I'm just rewriting the same thing, all right? And then they will say minus 1 plus b. And this is how they'd write their answer. And obviously that's 7 plus b over 8. This would be wrong. Okay, please not make this mistake. It is 100% wrong. What you should do is you should put brackets around it. So what you're going to do instead is you're going to say 8 over 8 minus, and then put brackets around 1 plus b. And then now you realize the minus is going to distribute itself with the 1 and also with the b, giving you 8 minus 1 minus b over 8, which is clearly not the same as what I had written before. So please do have your brackets when dealing with that. Okay, but for this problem, the answer, I believe, was 9 over 8. So that is that. Cool. Next problem. Now you can see over here it says write with positive exponents only. Okay, which obviously tells us that we need to ensure that the final answer has positive exponents, right? Which means that in this case, this p to the power of negative 2 cannot slide. Okay, and this q to the power of negative 1 cannot slide. I only want positive exponents, right? First of all, though, let me apply my rules, right? Just to keep things nice and simple and easy for me, I'll just separate them so I can just work with them separately. You don't need to, but just for my case and for my eyes and such, I'm going to do so. So that gives me the following. Okay, now this is p to the power of negative 2 divided by p to the power of positive 3. When I divide, remember we subtract the exponents, which means this becomes p to the power of negative 2 minus 3, right? And then multiplied by, this is q to the power of 3 minus negative 1, and that's basically that. And then obviously in this case that's negative 2 minus 3, that's p to the power of negative 5, and in this case that's 3 minus minus 1, in other words 3 plus 1, because a negative and a negative make a positive. And if you say 3 plus 1, that's going to become q to the power of 4. Now this is almost the answer. And this answer itself isn't wrong, as in the maths is not wrong, but you haven't answered the question itself. The question explicitly asks that you write with positive exponents only. Right now, I still have a negative exponent. So I do need to do just one last fix. Remember, this is p to the power of negative 5, but it's the same as p to the power of negative 5 divided by 1, first of all. And also it has its own imaginary or invisible multiplied by 1 in the numerator, right? So in other words, I can really write this as 1 as p to the power of negative 5 over 1, and just to be fancy, or extra, right, times 1, and then obviously multiplied by, and we're going to have q to the power of 4. Now, once you write this like this, you realize that this is the negative 5 can go to the bottom, but when you bring it to the bottom, we need to change the sign from negative to positive. If it was positive, we'd make it negative, right, vice versa. So this becomes, therefore, 1 over p to the power of 5 multiplied by q to the power of 4. Now, this can be simplified further as well, because remember, this is q to the power of 4, right? This is the same as just q to the power of 4 over 1. So this is 1 over p to the power of 5 multiplied by q to the power of 4 over 1. And this becomes q to the power of 4 divided by p to the power of 5. And that is your final answer. In this question, we also simplify fully and use positive exponents only, right? Not the best phrasing, but what I meant to be here was that the final answer should be with positive exponents, okay? So the idea behind this is that there's two ways you can really approach this, and you'll realize that any of the two ways, or I'm saying two ways, there's multiple ways to approach maths. Maybe there's more than one, more than two, but I'll focus on two different ways to approach it first, right? I can focus on what's in the brackets first, or I can apply this -1 first. Okay, so the first way I'm going to do is I'll focus on what's in the brackets first and try to simplify this as much as possible and then apply the -1. So just because I want to be fancy, I want to separate the 2 over 4, the m's and the n's, and just deal with them separately. You don't have to, but I'm going to do so just to make things a bit clear. Now, because I'm going to be introducing new sets of brackets, let me just keep square brackets over here so that we don't get mixed up. Okay, so in this case, I will keep my 2 over 4 as the first pair, and obviously I match up my m's. That'll be m to the power of -3 over m, and I'll match up my n's. That'll be n squared over n to the power of -1. So now I've matched everything up, right? Now I can simplify each block individually. Okay, and then because the brackets will be disappearing, let me just do that. Okay, so this is 2 over 4. That's the same as 1 over 2, so I'll just put 1 over 2 multiplied by, well, this is m to the power of -3, and I'm dividing by m. So when you divide, remember we subtract the exponents because they have the same base. M to the power of -3 is going to be subtracted by, there's an invisible 1 over here, right? Any number to the power of 1 stays the same. So that'll be m to the power of -3 minus 1, thus giving us m to the power of -4. I'll put that there, m to the power of -4. And then this is n to the power of 2 minus -1. So n squared minus -1, well, that's a negative and a negative, so we know that becomes a positive, and that gives us n to the power of 2 plus 1. That's going to give us n to the power of 3. So I'll be multiplied by n to the power of 3. Now, because I like to keep things nice and neat, what I'm going to do is I'm going to, first of all, just write them out as they present themselves, right? But just like this, because I need to combine them later. All right, when you write your multiplication like this, even if it didn't have even if it wasn't written as a fraction, when you write as a fraction, you're able to apply the multiplication very easily, right? Because when you multiply, it's just a matter of multiplying the top with the top with the top, and the bottom with the bottom with the bottom. Everything multiplies linearly. All right, it's in a straight line, horizontal line, that is. So that becomes 1 multiplied by m to the power of -4 multiplied by n to the power of 3, and then we just have 2 times 1 times 1. So I'll just write it as 2, and this is all raised to the power of -1. And now I personally, obviously, I've been told that no, we don't want to have negative exponents, so I want to give it, obviously, and make the exponents obviously positive by bringing the m to the power of -4 to the bottom. So that becomes 1 times n to the power of 3, and when m travels to the bottom, it finds already a 2 over there, so it's going to respect that 2, but also add its m to the power of 4, and that'll be to the power of -1. And then now we're going to apply the -1. Now what the -1 basically does is it takes everything that it sees and it basically flips it over. If something's at the top, it brings it to the bottom. If something's at the bottom, it brings it to the top. Now in this case over here, it applies to every single thing, top and bottom. If I had a over b to the power of c, this becomes a to the power of c over b to the power of c. Okay, if I had a times b times c over d times e times f to the power of g, right, it becomes, all right, on this side, a to the power of g multiplied by b to the power of g multiplied by c to the power of g over d, right? I'm saying, imagine there's a 1 over here, right? So what we're doing is saying 1 multiplied by g, 1 multiplied by g, 1 multiplied by g, so on and so forth, right? D to the power of g, e to the power of g, f to the power of g. Point is, this -1 will be shared because it's multiplication across every single person that it finds that is already over there, right? In other words, this is 1 to the power of 1. This becomes then 1 to the power of -1, okay? This is n to the power of 3. That becomes n to the power of 3 times -1, which is -3, over 2 to the power of 1. So this becomes 2 to the power of 1 times -1, so 2 to the power of -1. And then m to the power of 4 becomes n to the power of 4 times -1, and that's going to be m to the power of -4. That's basically that. So once you've done that, you can drop the negative, okay? But obviously, again, the problem says what? Write it using positive exponents only. So every person now has negative exponents. So how do I make them positive exponents? I just bring them to the bottom. So I'll just bring them to the bottom and I'll bring them to the top. All right, so I'll bring the 1 to the bottom whilst bringing the 2 to the top, multiplied by, I'm bringing the m to the top and bringing the n to the bottom. And as you can see, I change the exponents once I do the switch, and it's a 1, so I'll just leave the 1 out. No need to say it's a 1, and that'll be n to the power of 3. And that would be the final answer and the way that in which I'd approach this particular problem in this specific instance, right? Where I first simplify the inside first and then apply the things later, right? But you don't have to do that. You can work by applying the -1 first and then simplifying what's going to be inside afterwards, right? Which may arguably be a little bit easier in this case. So when we have something like 2 over 4 m to the power of -3, like this particular problem, right? The negative is my way of essentially teleporting the guy from the top to the bottom, right? So in other words, if this would basically be the same as 2 over 4, I'll bring all the negatives to the bottom. So I basically, well, I'll bring negatives to the bottom, the other negatives to the top. This becomes obviously m to the power of 3 times the m that was already there, and then there was already an n squared over here, but this n I'll bring to the top, and it becomes n to the power of 1, right? This is one thing that I could possibly do, where I move the things around by applying the negatives. Now, if there's a negative outside over here, then it just basically forces them to basically teleport and doesn't change their signs, right? It just makes them teleport from the top to bottom and from the bottom to the top. So what we're going to do over here is that obviously this negative is going to apply to every single person that it finds over there, right? Something to bear in mind is that if you have a problem like A times B times C and then D times E times F, and I'll just give them ones just to keep, oh, let me say 2, let's say 3, let's say 4, let's say 5, let's say 6, and they're all raised to the power of G. This then becomes A to the power of 1 times G times B to the power of 2 times G times C to the power of 3 times G over D to the power of 4G, E to the power of 5G, F to the power of 6G. You can see how I got lazy, so there was the end there. But that's the basic idea over here. So this -1 is going to come and apply itself to every single person over here, right? So when you imagine this becomes 2 to the power of -1, right? Multiplied by m to the power of -3 times -1. And that'll be n2 times -1. So you can see that all of them now, their signs seem to have changed, right? This is becoming obviously 2 multiplied by, this will obviously be m to the power of 3. This will obviously now be n to the power of -2, right? When I apply the -1. And then here I'm going to have again same thing, 4 to the power of -1 times m to the power of -1 times n to the power of +1, right? I need to change the sign of whatever sign I found there. All right, so this is, yeah, 2 to the power of -1, m to the power of 3, and then n to the power of -2. So then obviously this will cause them to swap sides, right? The 4 goes up, the 2 goes down, and because I'm swapping them over, you can see this -1 is now going to become positive, just exactly as it was before. This negative 2 to the power of 2 to the power of -1 is going to become again just a regular 2, just like how it was before. And again, same procedure. M to the power of 3 is made positive, so it stays now at the top, but now the n squared will teleport to the bottom, and the m over here will go towards the top. So this will be m to the power of 1. The n squared goes to the bottom, and then there's already another n of, well, this, yeah, and then the other n goes towards the top, which is going to be times n over here, right? So this is basically what I'm facing currently, okay? But that's by me going the long way around it. The easy way to just remember is that if there's a negative outside of the set of brackets, keep the numbers exactly as they are, but just swap them over. If it's a top, put it at the bottom. If it's a bottom, put it at the top. So I'm doing the exact same thing. I'm just obviously just showing what we're doing here. So I'll be just obviously 4 over, and then there was an m to the power of 1 over here. it's going to stay m to the power of 1 at the top. N to the power of negative 1 over here, it's going to stay n to the power of negative 1 at the top. And then same procedure with the 2 goes to the bottom times m to the power of negative 3 times n squared. Okay, and that's basically that. And then I can apply my rules to this. So obviously the first portion becomes a 2. This next portion becomes m to the power of 1 minus negative 3. And then this becomes n to the power of negative 1 minus 2. That's 2 times m to the power of 1 minus 3. That's, excuse me, that's 1 plus 3. That's 4. And then that's going to be n to the power of negative, have I messed up? It's negative 1. I brought negative 1. It's negative 1 minus 2. Right, negative 1. There was a 2 at the bottom. Yeah, it looks good. Okay, yes. So this is going to be 2m to the power of 4. And remember, we need to bring this guy to the bottom because it's a negative. So it'll be n to the power of 3, which is the same answer we got previously when we started on the inside and then apply the negative afterwards. So whichever one you find more intuitive, honestly, just do that. But yeah, it shouldn't really matter at the end of the day. Cool. And then moving on to our final 3 problems for this video. We're asked to simplify this. And this is where the tip I tell you, well, that you'll hear me say a lot when working with exponents, is to take any particular exponent and try to write it as a product of its prime factors. Okay, so if you have a Casio calculator, you should see, if you press shift and there's like a button with like a bunch of symbols like this or something like that. I don't have a Casio calculator on me, but check shift. Either shift or alpha, but I'm fairly certain it's shift, and then press this button, and then you'll see like there should be like facts in yellow though. So look for when there's facts in yellow. These are for the more advanced, obviously, Casio scientific calculators. This will basically give you your answer in terms of its prime factors, right? So I would advise to work with your answers in terms of their prime factors. And what you'll realize is that 27 is the same as 3 to the power of 3. Okay, so instead of writing 27, I'll just say 3 to the power of 3. Put it into brackets so you know that the 27 is 3 to the power of 3, and that 27 is raised to the power of 2 over 3. And now we're going to go to the same thing we did for the previous problem, where if you have a to the power of b and you raise it by some particular power c, when you want to drop the brackets, what happens is that you're going to multiply those exponents with each other. This becomes a to the power of b multiplied by c. It doesn't matter what b is, doesn't matter what c is. You'll see this is the exact pattern we have over here. This is like your a, this is like your b, and this entire block here is like your c, which means that this becomes then 3 to the power of b times c, 2 over 3. And you'll see that that's going to be 3 to the power of, the 3's cancel, and you're just left with squared over here, and your final answer is going to be 9. So that is how you would do a problem such as that one. Okay, and we're going to move on to this one. Now, again, these are going to be all powers of 2. Okay, so this is going to be 2 to the power of 6. All right, 64 is 2 to the power of 6, 1 over 3, and that'll be 2 to the power of 4. And you can check this with your calculator, of course, but 2 to the power of 4, I think, 2, 4, 8, 16, right? 2 to the power of 4, and then that is 16, but that's raised to the power of 3 over 4, and you divide that by 2 to the power of 3, which is going to be raised to the power of 2 over 3. And now I can multiply the exponents I can multiply the 6 per 1 over 3, for instance. That'll be 6 times 1 over 3, and then obviously that'll be 4 times 3 over 4, and then that'll all be over 3 times 2 over 3, thus giving me 2 to the power of 2 multiplied by 4. You see that these cancel out. We're going to have, I messed up. It's not 4, obviously. It's 2 to the power of 3. All right, because I've got 2 to the power of 6 times 1 over 3, which is the same as, obviously, 6 over 3. Right, and that's the same as just saying 2. This is 4 times 3 over 4, and the 4's cancel out, which can be left with 2 to the power of 3, and then you're going to have 2 to the power of 3 times 2 over 3. Now, 2 to the power of 3 times 2 over 3 is going to give us what? Well, the 3's cancel out, and we're just left with the 2 again. So that'll be 2 squared. So we're going to continue with that, and that will give us 2 to the power of 2 plus 3, because you can see that they have the same base, divided by 2 squared, which is the same as 2 to the power 5 divided by 2 squared, right? But obviously, again, 2 and 2. So what we can do then is you can say, well, we're subtracting because they have the same base and we're dividing. So that'll be 2 to the power of 5 minus 2. And then that will obviously be 2 to the power of 3, and that'll be just simply 8. So that is your final answer there. And then final question says that Swift compresses 3 power calculations into one line, and we're asked to simplify without using a calculator, which is what we just did. My bad. No, is what we just did. Okay, no, I skipped one. Okay, so we did this one. We didn't do this one. Apologies. All right, so this is 16. This is 2 to the power of 248, well, 2 to the power of 4 raised to the power of 3 over 4. And then in this particular case, again, I'm going to just multiply the top with the, well, you can do it. It's 4 over 1 multiplied by 3 over 4. If you want to do it in full, that's the same as saying 12 over 4, which is the same as saying 3. But you'll realize that the 4 cancels out with the 4 and you're left with the 3 anyway. So you would know that that's just the same as having 2 to the power of 3. And that answer also simplifies to being 8. And that is that. Hopefully you found this video helpful. Please join the free group chat to not miss out on other free resources and information.